Find the perimeter of the shaded triangle in terms of the square's side. Not much information has been given here, so we probably just need to start with what is given, or in fact what's not given. Let's say the side of the square has a length of n. We want to find the perimeter of this triangle here, and all we are given is the value of this angle. We aren't told what the values of these angles are, and so whatever the values of these angles are, the answer should be the same. That's what the question implies. So if you think about it, we can try making this value 0. The value of this angle, we can try to make it 0. What happens then is, this triangle, the triangle of interest, gets squashed here, right? The hypotenuse gets extended to the side of the square. This side of the right angle triangle gets extended again to the length of the square side, and this side becomes 0. It has been pushed down and made 0. So what we have here is not really a triangle, but then we know that the perimeter would be n plus 0, which is 2n. Right? So we have just moved this slided this triangle in such a way that this angle becomes 0, and therefore the perimeter of this triangle would become n plus 0. Though it's not really a triangle, we can be pretty sure that the perimeter of this triangle has to be 2 times n. Because irrespective of what this angle is, the perimeter should be the same. So yeah, if you were to take a guess in 5 seconds as to what the answer of this question is, you could do it that way. But a more satisfying proof we will need to find out. So first we will need to introduce right variables. We will need at least 3 because we don't know anything about this triangle at all. We don't know the values of any of its sides. So we could call it A, B and C, or we could call it A, B and P minus A minus B, where P is the perimeter that we want. Either way is fine. If this is B, this is n minus B, and if this is A, this is n minus A. So if you look at it here, you will see that A plus B is one of the values that is of interest to us, right? Because it is part of the perimeter. If you want to find A plus B, what can you do? As you saw in one of the earlier questions, one idea is to figure out what your auxiliary elements should be is to see if the sides of interest can be brought together or angles of interest can be brought together. Here we want to find A plus B, so it will be of use if we can bring the segments B and A together. Now to do that, we can't transform this triangle here because we don't know anything about the sides of this triangle. But what we can do is, we can bring these two segments together. What happens when these two are brought together? The length becomes n minus b plus n minus a, which is 2n minus a plus b. Right? It's quite easy to bring these two triangles together. Why? Because it's a square and this side has the same length as this side. So you can simply transform, in this case just rotate this triangle and bring it over here. That way n minus b and n minus a are brought together. Okay? Something like this. This triangle has been rotated and brought to this position. So we have brought n minus a and n minus b together, and therefore hopefully it leads us to the answer. because we have the a plus b term here. Now let's call this angle theta, then this is also theta. Let's call this angle alpha. It's easy to find alpha in terms of theta because this whole angle is 90 degrees, pi by 2, and therefore alpha is pi by 2 minus theta minus pi by 4. That is pi by 4 minus theta. So we have a value for alpha. Now we can also find the value of CAD, that is alpha plus theta. Alpha is pi by 4 minus theta. So alpha plus theta would be this plus theta, that is pi by 4, which means CAD is pi by 4. Now the answer is right in front of our eyes, right? We see that the triangles ACB and ACD are congruent. Why? Because AD is equal to AB. These both are the same triangles. AC is a common side, and the angle in between is pi by 4 in both the triangles. And so these two triangles are the same, which gives us BC equals CD. Therefore, 2n minus a minus b equals p minus a minus b, which gives us p equals 2n, which is the answer we want.